In this video, we're going to do a lot of practice problems finding indefinite integrals, that is, constructing antiderivatives. So first we're going to do just a bunch of integrals. Start with the integral of 2 plus 4x. Note that we could write this as the integral of 2 plus the integral of 4x, so kind of do each part individually. If you take the antiderivative or the integral of a constant, you just slap an x at the end of it, so that's just going to be 2x. And then this 4x, we're going to take the 4 out in front, and for the x, we're going to increase the power by 1 and divide by that power. So 1/2 x squared times the 4, make sure we don't forget the plus c at the end, and we could write this as 2x plus 2x squared plus c. And you can always check your work here by taking the derivative of the antiderivative that you found. And here you would get 2 plus 4x. That's what we want. Everything's good to go. We'll do that a couple times, then we'll stop checking after a while. But know that if you're ever not sure, you can check. All right, next one, x to the 6 plus 3x squared is going to be the integral of x to the 6th plus the integral of, we'll write this as 3x to the negative 2, so we can use the reverse power rule. The reverse power rule here says we're going to increase the power by 1 and divide by the new power. Same thing here, we're going to have 3 times increase the power by 1, that's negative 1, and divide by the new power, negative 1. Let's not forget the plus c at the end. And then writing everything out, we have 1/7 x to the 7th minus 3x to the negative 1 plus c. And if we do the derivative, just to make sure, the derivative of that function is, bring the 7 down out in front, it cancels out, we're left with x to the 6th. Bring the power down out in front, we get a plus 3x to the negative 2. And that works. Note the derivative of c is just going to be 0. All right, let's go on. So this next one, we have x squared plus 1 over x. And first, I want to talk about what you cannot do. So this is starting off wrong. You cannot do the integral of x squared plus 1 on the top over the integral of x on the bottom. Right? You can't bring the integral over division. That we can never do that, and that is a very bad mistake because you are really missing all of the details when we start getting into more complex antiderivatives in Calc 2. All right, so if that is something that you're thinking about doing, remember this, you cannot do something like that. You can't bring an integral over multiplication or division. So what we have to do here is we have to do some algebra. And there is some algebra to do to make this into a function that we can work with. I can write this as x squared over x plus 1 over x dx. So you can break up a numerator anytime. You can't break up a denominator, though. So note this is the integral of x plus 1 over x, if you cancel out the x, and that is going to be 1/2 x squared plus natural log of absolute value of x plus a constant. Let's write also something that's wrong that's going to pop up in a problem like this. You cannot cancel out an x out of just one term. So if you did, this would be written as the integral of maybe just like x plus 1 right? You cannot do that as well, right? We have to be very careful with our algebra and make sure that we're not doing some incorrect integral rules. All right, integral of 2 plus 4x squared. Again, we need some algebra here before we can kind of use our rules. We can write this as 2 plus 4x times 2 plus 4x. Note that this is not the same thing as the integral of 2 plus 4x times the integral of 2 plus 4x. Right? You cannot do stuff like that. You cannot bring an integral over multiplication. And just to make sure you're not even tempted to look at that too much, let's erase it. We can distribute everything, though, and write this as 4 plus 12x plus 16x squared. And now I can take the antiderivative of all of these. We have the 4x from that first term. We have a plus 12 times 1/2 x squared and a plus 16 times 1/3 x cubed plus c. So overall we get a 4x, 12 times 1/2 is 6x squared, 16 times 1/3 we can just write as 16/3 x cubed plus c. And once again, if you're ever unsure if what you're doing is correct, if you can get that as an answer, you can take the derivative and check to see if it works. All right, onward. The integral of 3 over 1 plus x squared minus cosine. So I'm going to write this as 3 times the integral of 1 over 1 plus x squared minus the integral of cosine. You can break up integrals in that form just as we would definite integrals. That's okay. And note that we have two straightforward antiderivatives, some rules we did before. 1 over 1 plus x squared is going to give us arctangent, as the derivative of arctangent is 1 over 1 plus x squared. And the antiderivative of cosine is positive sine, as the derivative of sine is positive cosine. And then there is our answer with the plus c at the end. Let's do a definite integral just to get some work with that as well. The same step, the first step is the same, we just have something to do at the end. We need to find an antiderivative. Note that the antiderivative of e to the x is e to the x. X to the pi, we need the reverse power rule here. That's going to be plus x to the add 1 to the exponent and divide by that new exponent. And that's as simple as you could write that. It's kind of gross, but that's what we have. Plus 4 at the end gives us a plus 4x. We don't add c, but we evaluate from 1 to 2. So we plug in 2 and we subtract off plugging in 1. So you write that here. We're going to plug in 2. Here we're going to plug in 1, and we're going to subtract. So we have e to the 2, e squared, plus 1 over pi plus 1, x to the, sorry, not x, 2 to the pi plus 1, plus 4 times 2, and then the same thing plugging in 1, e to the first, 1 over pi plus 1, 1 to the pi plus 1, 4 times 1. There's some simplifying you might be able to do there. No plus c at the end. Remember, for a definite integral, we're finding an area under the curve, our answer should be a number. Indefinite integrals are finding a family of functions that should be not a number, but a bunch of different functions with that plus c. Make sure you're doing the right thing, you're not getting them mixed up. All right, different kind of problem now. Find an antiderivative of f prime equals cubed root of x squared minus e to the x with f of 0 equals 2. And we're going to deal with that f of 0 equals 2 at the end of the problem. So first, let's find an antiderivative of that function. That means that I'm going to take the integral of that function, cubed root of x squared minus e to the x. That's the same thing as x to the 2/3 power minus e to the x. So we're going to add 1 to the exponent there. That's going to be x to the 5/3. And we're going to divide by that new exponent, 5/3. And the antiderivative of e to the x is e to the x. We're going to have a plus c. So this is all antiderivatives of the function here, f prime. What I want to do is I want to find one antiderivative with f of 0 equals 2. So note that what I found here was f of x. So I'm going to set up an equation to solve for c and find a single antiderivative. This represents all antiderivatives, but if I do a particular value of c, it represents one of them. So here I have f of 0 is 1 over 5/3 is the same as 3/5. 0 to the 5/3 minus e to the 0 plus c. All of that is going to be equal to 2. F of 0 is equal to 2. So here's my equation. 0 to the 5/3 power is 0. E to the 0 is 1. Plus c is equal to 2. So that means that c here is equal to positive 3. So the specific antiderivative that I'm trying to find here is 3/5 x to the 5/3 minus e to the x plus that constant 3. This is what we call an initial value problem. And you'll see these a lot as we move forward with antiderivatives. That is, we're trying to find a specific antiderivative by solving for c for some value. And we're given some initial value. Last few questions. We have a bunch of statements here. I want to see if these are true or false. So the first one, the integral of e to the 2x is 1/2 e to the 2x plus c. We don't need to know any rules to see if that's true or false. We can just take the derivative of the right-hand side and see if it equals e to the 2x. So the derivative of 1/2 times e to the 2x, we'll say plus c as well, is going to be using the chain rule, 1/2 times 2 e to the 2x plus 0, and that is e to the 2x. So that means that this statement is true. This is a little bit beyond the kind of integral we're going to do in Calc 1. It's a very simple application of something called substitution, which will be the first topic in Calc 2. All right, the next one is not true. We can verify that by just taking the derivative here. The derivative of 1/2 x squared times sine of x. We need the product rule there. And that's not as simple as just taking the derivative of one part times the other. That would give us a x sine of x plus 1/2 x squared cosine of x. And that's definitely not the same thing. This is false. Why did I want to bring up this one in particular? That's because this is our wildly incorrect rule that someone probably did, the integral of x times the integral of cosine. You do the integral of each part separately and you get 1/2 x squared times sine, but that's not true for the same reason the derivative rule of multiplication is not true. You have to do something more complicated in that case. This is an integral you can do with something called integration by parts, which is kind of going backwards through that product rule, and you'll learn that in Calc 2 as well. Right, so we cannot do stuff like that. This is false. The next one is true using the power rule, right? You increase the power of x by 1 and you divide by that new power. And note that 7,048 over pi squared is just a constant. You could bring it out in front and deal with that x to the 7th. However, this problem is false, the whole thing, because there's no plus c, right? So if that plus c is not there, then that is not the right answer, just to make sure we're right with that one. All right, the next one, take a look at it. We have sine over cosine. Note that's actually the integral of tangent, is what we're doing there. And we get negative natural log of cosine. And at first glance, that may seem like that's definitely not true. Maybe to do this integral, you want to do the integral of the top over the integral of the bottom, but you cannot do stuff like that. So you remember, you can't do that. But we can test this is true by just taking the derivative of negative natural log of absolute value of cosine of x. We need the chain rule there. The derivative of negative natural log is going to be negative 1 over something. We are going to leave the inside alone, and we're going to multiply by the derivative of the inside. The derivative of cosine is negative sine, so this is going to give us negative sine over cosine, which is what we need in this problem. So this is true, although it may not seem like it from the beginning. And this is maybe a lead into thinking about the rest of this course and also the beginning of Calc 2. Derivatives, which we did in Chapter 3, are really quite straightforward. We have a number of rules, and if you know those rules, you know how to apply them, you can take derivatives of any function fairly easily. You just need some practice getting used to those rules. Antiderivatives and integrals are much, much more complicated. We have some rules that are just very quick, we can do them. We went through those in this section, but it becomes much more complicated much more quickly, and you'll spend the first month of Calc 2 talking about those kinds of techniques you can use to find some of these we did on this page, actually. Then past that, there are some functions that you cannot find antiderivatives for. And we'll talk about that a little bit in the next video, that some simple functions, there's no nice way to write down an antiderivative. And that is, again, much more complicated than derivatives.